An iterative process is a repetitive process where we keep putting our answer back into a formula to get the next answer. Here we've got a question that says the size of an investment t years from now is x, where x0, the initial x, is 15,000, and xt plus 1 equals 1.05 times xt plus 500. This means the next answer is 1.05 times the previous answer plus 500. So x1, which will be our first answer, is going to be 1.05 times x0, which is 15,000, plus 500. Then we're going to put this answer, x1, back in to find x2. So x2 will be 1.05 times our first answer, plus 500. And then x3 is going to be 1.05 times our previous answer, x2, plus 500. So let's have a look at how this works. So we're going to start by putting 15,000 in. That's our first one. So we're going to work out x1 by working out 1.05 times 15,000 plus 500. And we're going to use a calculator to work this out. And what we can do is we can put 15,000 in, press equals, and then it becomes our answer. So if I press my answer button now, I get 15,000. So what I can do is in the calculator, instead of writing 15,000, I can write ANS now. So in my calculator, I'm going to do 1.05 times ANS, the answer button, plus 500. So 1.05 times ANS plus 500. And that gets me 16,275. So we can say x1 is 16,275, probably pounds, but it didn't say in the question. And then x2, we're going to do this again. So it's going to be 1.05 times 16,275 plus 500. But that is my answer now. So the calculator, if you press equals again, will automatically substitute it in for you. So you just press equals again, and we've got 17,613.75. And for x3, we just press equals again. So we've got 19,019, probably pounds, and 44p. Okay, one of these for you to try, so give this a go. So the size of a debt t years from now is D, where D0, the initial number, is 95,000, and dt plus 1 equals 1.02 times dt minus 6,000. So to work out d1, we're going to put 95,000 in. So it's going to be 1.02 times d0, which is 95,000, minus 6,000. So we can type that into the calculator. We'll use the ANS button again. So 95,000 becomes, if you press equals, that will become the ANS button. So we can do 1.02 times the answer minus 6,000. So 1.02 times answer minus 6,000. And we've got 90,780. And then to get D2, we just press equals again. So it's going to substitute that into the ANS for us. So press equals again. We've got 86,475.6. And one more time. So just press the equals button again for 3. So 82,085 and 11, probably pence. The most common use of iteration is to solve an equation that we can't solve by another method. So here is a full question. Part A says, show that the equation x cubed plus 2x minus 7 equals 0 has a solution between 1 and 2. So if we put the solution in, if we substituted the solution in to x cubed plus 2x minus 7, it would equal 0. And if there's a solution between 1 and 2, that means one of them will be too big and one of them will be too small. So if we substitute 1 in and substitute 2 in, one should be bigger than 0 and one should be less than 0 if there's a solution between them. So let's substitute them in. So if we substitute in 1, it's going to be 1 cubed plus 2 1s minus 7. 1 cubed is 1 plus 2 1s, so 1 plus 2 is 3 minus 7 is negative 4. And substitute 2 in, so 2 cubed is 8 plus 2 2s, 8 plus 4 is 12, minus 7 is 5. So we've got 1 above 0, 1 below 0, so 1's too big, 1's too small, so there must be the answer between them. So that shows that there is a solution between 1 and 2. So 1 positive and 1 negative. Therefore, solution is between 1 and 2. Show that x cubed plus 2x minus 7 equals 0 can be rearranged to give x equals the cube root of 7 minus 2x. So how can we rearrange this into this? So if we plus 7 to both sides, we'll get x cubed plus 2x equals 7, and then take 2x away from both sides. We'll get x cubed equals 7 minus 2x, and then cube root both sides. We have rearranged to get x equals the cube root of 7 minus 2x. And what we've done by rearranging it to get x by itself is we've set up an iteration formula. So you see that this changes into xn plus 1 equals the cube root of 7 minus 2xn, which is the iteration formula. So this becomes the iteration formula in part C, and part C says use it 3 times, starting with 2, to find an estimate for the solution, for a solution to our equation. To find x1, it's going to be the cube root of 7 minus 2 times 2. So we're going to put 2, we're going to start with 2, so we put that into the formula first. And I'm going to put 2 into my calculator first, press equals, so it becomes ANS. And I'm going to do cube root 7 minus 2 times the answer. which is 2. And I've got 1.44224 and so on. And then I'm going to work out x2. And all I've got to do to work out x2 is press the equals button. So I've got 1.6025 and so on. And x3, just press the equals button again one more time, and we've got 1.55979 and so on. So we've done it 3 times, so we could either leave our answer as this or round it to 2 decimal places. Either way, we've done it 3 times, and that is now our estimate for the solution to the equation. So every time we do this, the answer will get closer and closer to the actual solution. Okay, one for you to try, so give this one a go. Part A, show that the equation x cubed minus 3x squared minus 4 equals 0 has a solution between 3 and 4. So if the solution's between 3 and 4, one will be too big and one will be too small, which means that one of these will give a positive answer and one will give a negative answer. So let's substitute them both in. So we'll do 3 cubed minus 3 times 3 squared minus 4. And we'll do 4 cubed minus 3 times 4 squared minus 4. So I'm going to use the calculator. So 3 cubed minus 3 times 3 squared minus 4. So that's negative 4. And for 4, I'm going to change the 3's to 4's. And that's 12. So one's positive, one's negative. That means a solution must be between them. And that means there's a solution between 3 and 4. Part B, show that x cubed minus 3x squared minus 4 equals 0 can be rearranged to get x equals 3 plus 4 over x squared. So if we add 3x squared to both sides, so x cubed minus 4 equals 3x squared, and then add 4 to both sides, x cubed equals 3x squared plus 4, and then divide both sides by x squared, or divide every term by x squared. That will give us x equals 3 plus 4 over x squared. So now this is going to become our iteration formula in part C. And it's going to be rewritten as xn plus 1 equals 3 plus 4 over xn squared. And we're going to use it 3 times, starting with 3, to find an estimate for the solution to the equation. So let's start with 3. So x1 is going to be 3 plus 4 over 3 squared. But again, I'm going to use my ANS button, and I'm just going to type it in. So 3 plus 4 over answer squared. So I've got 3.4 recurring for x1. For x2, I'm just going to press the equals button again. So it's 3.33714 and so on. And x3, just press equals again, and we've got 3.35917 and so on. And that is our estimate for the solution. So each of these is more accurate than the one before it. And if we kept going, we'd get increasingly accurate estimates. Okay, another one, practicing using the iteration formula. So use the iteration formula, xn plus 1 equals the square root of 2xn plus 10 all over 3. We're going to use it 3 times, starting with x0 equals 2. So put 2 in first to find an estimate for the solution to this equation. So x1 is going to be the square root of 2 2's plus 10 over 3. And again, we're starting with 2. So we'll put that in as our a and s. And we've got 2 times answer plus 10 over 3. So the square root over all of it, 2 times answer plus 10 over 3. Press equals. So we've got 2.16024 and so on. So 2.16024 and so on. For x2, we're just going to press the equals button again. The calculator is going to use this as the answer. So press equals again, 2.18483 and so on. And for x3, press equals one more time, 2.188581 and so on. And there we have 3 times. So 3 increasingly accurate approximations for the solution to the equation. And one for you to try, so give it a go. So this time x1 is going to be the square root of 9 over 2x0, which is 1.5, 2 1.5s plus 5. So we're putting 1.5 in first. We'll use the A and S button. And then we're just going to type it in. So it's 9 over 2 times the answer plus 5. So we've got 1.06066 and so on. We're going to press equals again for x2. 1.12419 and so on. And press equals one more time for the third one. 1.11429 and so on. And there we have 3 times, so increasingly accurate answers for the equation. And to finish up, we've got one more question. So pause the video and give this one a go. Part A, show that the equation x cubed plus 3x equals 2 has a solution between 0 and 1. So if we substitute in 0 and 1, 1 will be too big and 1 will be too small. So 1 will be higher than 2 and 1 will be lower than 2. If you wanted to make it equal to 0 first, so take 2 away from both sides, and then one answer will be positive and one will be negative. It doesn't matter which one you do. So if we do 0 cubed plus 3 zeros, well, that's 0. So that one's too small. And 1 cubed, which is 1, plus 3 ones, which is 3. So 1 plus 3 is 4. That one's too big. So 2 is between. 0 and 4. So therefore, a solution is between 0 and 1. Show that x cubed plus 3x equals 2 can be rearranged to give x equals 2/3 minus x cubed over 3. So we're going to take x cubed away from both sides. So 3x equals 2 minus x cubed. And then divide everything by 3. So x equals 2/3 minus x cubed over 3. Now this is going to become our iteration formula. And we're going to use it 3 times, starting with 1, to get an estimate for a solution. So x1 is going to be 2/3 minus 1 cubed over 3. And we're going to use the calculator. We'll use the A and S button, so make sure 1's down as the answer. And then we'll just type it in. So 2 over 3 minus the answer cubed over 3. So we've got 1/3 as our first one. So x1 is 1/3. x2, just press equals again. And I'll leave it as a fraction, so 53 over 81. And x3, press equals one more time. And it's 0.573287, and so on.